In this video, we're going to look at two questions on the topic of simple harmonic motion. So for question 1, it says an oscillating pendulum bob has a maximum angle of swing theta. In its lowest point, the tangent in the string is n times the weight of the bob. Obtain expression for cosine theta in terms of n. So my idea is that we can use the conservation of energy to figure out the speed of the bob at the lowest point, and then we can calculate the tangent. And then we can relate the tangent to n and then to cosine theta. Okay, so first of all, I'm going to draw a diagram. So the basic idea is that we say this is the vertical and then there's a bob. So the maximum angle of swing is theta, and it's also given us that when the bob is at its lowest point, it's n times the weight of the bob. So first of all, the conservation of energy. And then, so basically we can cancel out the m. So what is the change in height? The change in height, let's say let's say it's the length of the string is L. I think we'll be able to cancel it out later. So this will be L minus L times cosine of theta. And this is equal to half V squared. And then, so let's see. V squared will be simply equal to 2GL times 1 minus cosine theta. I factor out the L from within the brackets. Okay, so now we know V squared, and then we can tie this back to the tangent. So the tangent is basically equal to the centripetal force plus the weight of the bob. So let's see. What we know is that n, so T is basically also equal to n times the weight. So let's see, so but there's one thing we can actually factor out of these, which is the mass of the object. So what's left will be AC plus G is equal to n times G. And then, so in this case, this will be equal to 2GL times this is 1 minus cosine of theta over L, which is R, plus G is equal to n times G. And then we can solve for cosine theta. So basically the L cancels out with each other, and then so basically n minus 1 times G is equal to 2G 1 minus cosine of theta. So let's multiply out the brackets. So basically n minus 1G is equal to 2G minus 2 wait, no, I can just divide it to the other side. Yeah, so basically divided to the other side over 2 will be equal to 1 minus cosine of theta. So therefore cosine of theta in terms of n will be equal to 1 minus n minus 1 over 2. And let's write it in a single fraction. In the single fraction, this will be equal to this will be 2 minus n plus 1, so that's 3 minus n over 2. And this will be the answer to the first question. Now let's look at the second question. It says, a simple pendulum consists of a small mass on the end of a light and extensible string, as shown in figure 1. It swings from an initial angle of theta is equal to 14 degrees, for which it will have a period of t0. but it hits a wall elastically, which is at an angle phi is equal to 7 degrees to the vertical. What is the new period of the oscillation in terms of t0? And then it gave us theta and phi are small angles. Okay, so my idea is that we can first start off with a graph of displacement against time to see what exactly is happening. This will be equal to, this is the displacement axis, and this is the time axis. So first of all, we can see, like, we can take the right side as the positive side, so it will start at the top. It will go like this, so this is a cosine curve. And then, so this is the maximum point. So let's say it's an angle, so it's the degree, so it's the angle, let's say. And then over here, this will be the 14 degree, and then over here, this will be equal to negative 14 degree. So when does the small mass hit the wall? Because it's given the question that theta is equal to 14 and then phi is equal to 7, so basically phi is just equal to theta over 2. So over here on the diagram, it will simply be like this. So that's around over here. And then this is, I would say, half the new period. So this is negative 7 degree. So how do we link this back? Okay, so my idea is that we can write a function for the simple pendulum. Now in this case, it will be in the form of, let's see, it will be in the form of x is equal to x0, right? x0 times cosine of omega times t. Now, in other words, we can also convert this into angle. So basically, negative 7 is equal to 14, which is initial times cosine of omega times t. So what we want is t, however we don't know omega. Now we have to express omega. So omega in this case will be simply 2 pi over t, and then it will be t0. So let's put this back into this equation. So basically cosine of 2 pi over t0 times t is equal to negative 1 over 2. Okay, and then so therefore 2 pi t over t0 will be equal to cosine of negative 1 over 2, and that's, we need to express it in terms of radians. So if cosine is equal to negative, so that's 120 degrees, 120 degrees is 2 over 3 pi. And so t will be equal to times, and then you can cancel out the pi, divided by 2, this will be 1 over 3 t0. Okay, and then one thing we have to understand is t is equal to t over 2. So the new period will be simply equal to 2 over 3 t0. And this will be the answer to the second question.